This is question 16. Here we're told that A, B, C and D are points on the circumference of a circle centre O. That's going to be important. We'll refer back to that shortly. Then we're told that angle AOC is equal to Y. We're given that there. And we're asked to find the size of angle ABC. So ABC, that angle there, in terms of Y. And we're asked to give a reason for each stage of your working. Now, with a circle, so this is a circle theorems question, and when we have got a circle theorems question, at the beginning it's good to think about what possible circle theorems we could use to solve the problem. Now, this first bit of information is important. We're told that A, B, C and D are points on the circumference of a circle. So A, B, C and D are all on the circumference, which means that we have got a cyclic quadrilateral, which means then that we can use one of our circle theorems which relates to cyclic quadrilaterals. And that circle theorem is that the opposite angles, so this angle here that we've marked, ABC, that the opposite angles, so ABC and ADC, that they will sum to 180 degrees. So that is one circle theorem that we could potentially use. The other circle theorem that we could potentially use is that we have been given an angle at the centre. We're told that angle AOC, which is marked, will be Y. What we can then say is that the angle at the centre, again this is another circle theorem, the angle at the centre is twice as large as the angle on the circumference. So if I can write this angle ADC in terms of Y, that means I can then write angle ABC in terms of Y. So let's start off by writing ADC. So the angle ADC is going to be, now what we're saying is that the angle at the centre is twice the angle at the circumference. So, or we can think of it as the angle at the circumference is half the size of the angle at the centre. So ADC is going to be Y divided by 2, half of Y. So I can write that there, Y over 2. So angle ADC is Y over 2. And our reason, it says give a reason for each stage of your working. So the reason for this that I can write down, the reason is going to be that the angle at the centre is twice the angle at the circumference. So ADC is equal to Y over 2, and the reason that the angle at the centre is twice the angle at the circumference. Now, secondly, we can now figure out what ABC is going to be. ABC is going to be, and what we said at the beginning is that on a cyclic quadrilateral, which we've got here, is that the opposite angles in a cyclic quadrilateral will be 180 degrees, add up to 180 degrees. So this angle ABC is simply going to be 180 degrees minus the opposite angle, because the two angles ADC and ABC have to add to 180. So that means that this angle ABC will be 180 minus the opposite angle. And our reason for that? Our reason is that opposite angles on a cyclic quadrilateral sum to 180 degrees. So final answer here, angle ABC is equal to 180 minus y over 2. And because it says give a reason for each stage of your working, those reasons are going to be important and can form as much as it will probably be 1 mark for each reason that you give and 2 marks for your final answer. So those reasons are really important. So final answer, angle ABC equals 180 minus y over 2.